We are going to take our first look at circles and their different parts and terminology and different properties that they have. So the first question that we of course need to ask ourselves is, well, what is a circle? And whenever I ask this question, I usually get a lot of different answers. As far as it's something that's round, or maybe it's a polygon with infinitely many sides, or all these kind of imprecise definitions. And so, if we want a really good definition, just like when we talk about lines or segments, they're collections of points, and circles are collections of points as well. It's just that circles are collections of points where every single point on that circle is equidistant from a given point, which is that center. So that is my definition for what a circle is. It's a set of all points in a plane, that's the important part that we'll talk about here in a second, that are equidistant from a given point. And this point that they're all equidistant from is, of course, called the center of the circle. So, so if I were to draw a circle here, draw a really rough sketch for a circle, I've got this center point here in the middle, and every point along the outside of this circle is the same distance away from it. That's the collection of points. And so this in a plane part is only a little bit important here, because if I just told you that it's a set of all points that are equidistant from a given point, you'd probably come up with this as well. The reason that this in a plane is important is that if I didn't put that in, we'd actually be describing a slightly different shape, and that, of course, would be a sphere, which we'll define at a later point. So that's why it's all the points that are in a plane that are equidistant from a given point. So then, one of these other common terms you've almost definitely heard of is a radius. And a radius is just a segment whose endpoints are the center and then any point that's actually on the circle. So starting at the center and then going to a point that's on the circle, this is what a radius is. This is a radius. And let me actually name these points too, because I guess I haven't talked about how to actually refer to this. So this is point O. We'll call this point, I don't know, R. So when I talk about this, this will be circle O. We always name it based off of where the center point is. And then this radius here would be, in this case, the segment OR is the radius. So a radius is just a segment whose endpoints are center and any points on the circle. And then a chord is something that if I pick 2 points that are on the circle, the chord is the segment that joins those 2 points. So this is a chord. I'll name these two. Let's go with A and B. So this will be chord AB, which is also just a segment, but it's just a segment that has 2 endpoints that are on the circle. And then, of course, our diameter. Diameter is just a specific type of chord. It's a chord that goes through the center of the circle. This would be my diameter, so we'll call this C and D, and this would be my diameter then, which is segment CD. Okay, so these are all the basic, or probably most basic parts of the circle. We have our definition, and then we have, these are all, this is going to be an important takeaway here in a little bit, and I realize that's a little bit off the screen, but these 3 things are all segments. Radius, or radii, chord or chords, and then diameter or diameters, they're all just segments in a circle. Because we're also going to talk about some things then that are not segments in a circle, but rather lines, and that's the next thing we're going to talk about. So our next set of definitions then would be a secant and tangent lines. These are both lines. That's an important distinction to make here. These are both lines. And so if I have a circle, again, I have my center point here. So a secant line is a line that intersects a circle in 2 points. And so what you could think of this kind of as is that this is like the, if we were to continue a chord, what I would get is a secant. So, or rather, maybe a chord is a portion of a secant. So this would be, I should name this as well. So this is secant AB, it's a line that goes through those 2 points that are on the circle. And this is one that might be a little bit tough to understand, but we'll spend a whole bunch of time with it, and that's this. A tangent line is a line that's in the same plane of a circle that intersects a circle in exactly 1 point. So instead of going through 2 points here, we're actually going to pick just a point, and I'm going to just touch the circle and then go away. And so if I intersect at just a single point, so just barely touching the circle, This would be called a tangent line. So in this case, this would be tangent line CD. So CD is a tangent line to my circle here. And this point right here, we're going to call this is my point of tangency. One thing you might be asking yourself right now is, does this have anything to do with the tangent we talked about earlier? And the answer is kind of, but not really, not for us right now. And so, yeah, these are both lines. That's the important distinction here between, here, let me flip back real quick. Go away. Bring us back. These are all segments, radius, chord, diameter, which are all kind of then portions of, or can be portions of, my other things that I have, which are, let's see if I lost them all. There we go. Secants and tangents, which are my lines then. So these are all my kind of basic definitions that go along with circles. I'm going to add one more thing here, which is actually a theorem, which is about tangents, and it is this. So it says that if I have a circle, so let me start off by that. If I have a circle, that's just no good. If I have a circle, that's not any better. I'll give it one more try. Okay. If I have a circle, and a line is tangent to that circle, let's draw my tangent line. Tangent lines just goes and touches one point. Then the radius that goes from the center to that tangent line will make a right angle. So my tangent line here is always going to make a right angle with the radius that goes to this point of tangency. So this point where my line intersects my circle, this point of tangency here, if I draw the radius to that point from the center, it will make a right angle with my tangent line. The reason for this, we can give a real quick justification for this, because the question you might ask yourself is, well, couldn't there potentially be multiple tangent lines that kind of go through this point but don't make a right angle? And the answer is no. And the reason for it is you can think about it in this way. So if you think about all the points that are on this line, if I think about all the points that are on this line, they're all some distance away from the circle. But I can guarantee you that every point on this line is farther away than the point of tangency is to my center. And the reason for that is because every point out here is outside of my circle, except for one, and that is my point of tangency, which is on my circle. So every point, since it's not inside the circle or on the circle, has to be farther away. And how do I know, or what do I know rather, about the segment that I can draw that's the shortest distance from a point to a line? Well, we know that that is my perpendicular segment. It's got to be a perpendicular segment that goes from my center to this point of tangency. It's got to make a right angle. That's my shortest distance. So this has to be the point that's closest, which would mean that it has to be on this perpendicular segment here. So that's kind of my justification as to why. So that's an important fact, and we'll use this a whole bunch here. In fact, some people might even make the justification that this is the definition of what it means to be tangent, that it makes this right angle that goes through one point of the circle and makes a right angle with the radius of that point. But we've extended it as a theorem. So those are all kind of the basics of circles that I'll need moving forward, so that we can build off of.